late. Today, I will talk about building a healthcare assistant with VertexAI. Actually, uh, between the time I suggested this presentation and the time of the presentation, there is no longer VertexAI. It's called Agent Platform. We'll explain in a moment. MedGemma and Gemini. Good. Now, a few words about myself. I joined the Google Developer Expert program as a Kaggle Google Developer Expert in 2024. And the next year, I also joined the AI GDE program. Right now, after GDE reorganized, AI became Cloud AI, and the former AIML became now AI, and so I'm only in AI GDE because Kaggle was as well discontinued. So a lot of transformation in the space of GDE program, but also, as you'll see in a moment, a lot of transformation with Google Cloud Platform. And on my day job, I'm a principal data scientist at Endava. If you want to connect with me, you can scan this QR code on the right. This is my LinkedIn profile, and so we can connect. And of course, continue discussing about everything AI, agentic, and how we can implement AI-based solution with Google Cloud. Now, today's agenda, I must say, I was still refining a bit the presentation when I was invited to join early/late. Today's agenda, introduction, AI with Google Cloud, and I will say a bit more words than normally here because a lot of things change with Google Cloud, especially in the VertexAI, what used to be called VertexAI, and I want to take this opportunity to present a bit about this as well. It's very recent, it's less than 1 month ago, and probably some of you didn't actually even notice these changes yet. Then I will continue with a few words about ADK, which is the agentic framework from Google. And the core of the presentation, it's about two things. First, it's about MedGemma, which is a model that was created, was derived from Gemma series, started with the Gemma 3 and with MedGemma, the first edition, and now before launching Gemma 4, Google DeepMind also launched MedGemma 1.5, which is even more advanced variation, if you want, of the from the Gemma series, a model that is dedicated for analyzing images and general healthcare. And then I say the core of the presentation will be around one application that I started to build it just as a simple chatbot to expose actually functionality of MedGemma to basically to interpret medical images. But then using Antigravity, I transformed these from a very simple application to something, to an agentic application that, as you'll see, will have multiple functions and also will add important new features. And then the first implementation that I obtained using Antigravity, it was quite complex agentic application, but not using ADK. So the first solution that Antigravity chose, and you'll see I've actually adopted the way to work with Antigravity, where I let a lot of liberty to the agentic IDE. So the first attempt was to build something agentic, quite complex, maybe too complex, but not using ADK. And so the third version of the application also using anti-gravity. So the evolution step 2 from the rather complex and maybe over-engineered version of an agentic healthcare assistant, I changed it to use ADK to be much simpler, and while doing more or less the same functionality. Now, let's start. So, by the way, this is a link for the project. I'll give you more details while we are advancing. And so you can scan this QR link, clone the code, and you'll see you have more several branches there. By the way, I didn't push yet the code with the implementation with ADK, so we'll do it actually most probably during the presentation, so that you will have access to it. Now, so you can scan the QR code and you'll get access to the second version of this application. It's already on mail. As I said, we start with the introduction to AI with Google Cloud. Good. So it used to be in Google Cloud, everything about AI, ML, generative AI as well, around VertexAI. But recently, that means the announcement was during Google Cloud Next, it became Gemini Enterprise Agent Platform, replacing what used to be VertexAI, so less than 1 month ago. And with this change, the most functionality for training, evaluation, deploying, monitoring remains under models. The reorganization will create this new structure where the rather complex and verbatim structure of the VertexAI, let's say, subsection in GCP is now organized around studio, models, agents, and notebook. Studio, it's about building agents and applications with the most advanced models. With models, you still have the models accessible in Model Garden as before in VertexAI. So Model Garden remains Model Garden, and you still can do everything you're doing before. That means if you want to build like production-ready application using machine learning, you can do model tuning, evaluation. You can use model registry to keep track of your trained models, and you can perform inference using either batch inference or model endpoints where you deploy and serve models that you either train or you pick up, so pre-trained model from Model Garden. And then you can centralize model from the experiments. You can use data sets and feature stores for centralized access to data and features. And so with feature store, you can manage both your online and offline features. And so you can you can speed up the serving of your models by preparing data needed for inference. Then with the model pipelines, you can do enterprise level model training, evaluation, registry, and serving. And as well, you can, as before, monitor models with monitoring. So everything is still in place, didn't disappear, but it's a bit reorganized. Now, because VertexAI becomes agent platform, you probably figured out already that agents are a central part now on Google platform, Google former VertexAI platform, which is now agent platform. And here you still have the agent garden, where you can create application with ADK, Reg Engine, MCP servers, vector search. So everything you need to build an agentic application. And you can perform deployments. You can use memory bank sensation for modeling medium or long-term memory as for your agents. And you have also tools to optimize your agents and evaluate them with topology and agents evaluation. Now, for the experimenting part, if you want to start working with ML, you want to use maybe notebooks or collabs, you still have a workbench. This is a typo. It's not workbook. It's a workbench. Okay, GCP workbench or collab notebooks. So they are under one big section, only two option now, and of course now all the workbooks are managed. So also a bit of simplification here. Now a bit more about the agent platform. Some things remain as they were, some things were renamed or reorganized. So agent will be now agent runtime, agent build station are now agent platform station, memory bank become agent platform memory bank. In the agent platform, you have now only one place, centralized the tools and services for ensuring agent identity, which helps you to let your agent securely authenticate to MCP servers, cloud resources, endpoints, and other agents. Agent gateway, which secures and governs connectivity for all agent interaction. Agent registry, let's call it the equivalent of the model registry, but for agents, which is a centralized unified catalog that lets you store, discover, and govern model, context protocol, servers, tools, and agent with Google Cloud. And for agents observability, you have as well the functionality in place. So with agents observability, you ensure visibility for performance, behavior, and health for deploying agents and MCP servers. Few words now about, so a lot of changes and a lot of reorganization in the structure of what used to be VertexAI, now agent platform. ADK, now which started, by the way, ADK stands for Agent Development Kit, framework for agentic AI from Google. It's open source, but Google is sponsoring and pushing a lot. Now ADK is part actually of agent platform. It's the agentic solution, agentic framework of choice. Few words about it. In terms of agent structure, all agents are derived from a base agent. And we have basically three main types of agents, two predefined and one custom agent. So basically you can create by deriving from base agent your own breed of agents. The main two predefined are LLM based, which are all about reasoning tools, transferring data, and the workflow agent, which are modeling sequential parallel loop workflow. And you can assemble these various types of agent to create to model different workflows to create agent orchestration. And so this is, let's say, the basic class structure of ADK agents. So we have base, from it is derived LLM and workflow agents. So when you build an agentic application ADK, you can have an agentic equipped with agent tools and function tools. And so you can model totally flexible workflow, but you can also use predefined workflow with workflow agent. In terms of running, actually running the code that it's implemented using ADK, there are few key elements. So the most important is the runner, which is the main event processor for ADK. So you have here you have event loop. So let's say when user input is presented to the ADK implemented to the application implemented using ADK, and you have the runner that will process the event loop, will start by processing the initial user input, and then according to the structure of your application, you have a certain execution logic. So in each event loop, you'll have an input and an output. So each parent agent will process its input, will use other agents or tools to answer to the questions according to the input to the query, and then will provide an answer. And the runner is using also external services, the session or state, different artifacts, and also is managing memory, and it's operating whatever storage is associated with storing the short-term or long-term memory. Here's an example of processing this event processing process. So let's say an agent will start by processing a request. Then what can happen is we might have a LLM call, could be a reasoning or a tool selection could happen. And then let's say a tool was selected, then you'll have a function call, which will pass the tool name plus the arguments. Let's say it's a tool that receive an image, so image should be, maybe you should extract and process that image. And then you have the framework with execute the tool, and the tool ADK, it's really abstractizing the notion of a tool. So a tool could be an agent tool, could be an action Python function, or an API call. So after the framework return the result of execution of the tool, agent will process the result, and most probably a large language model, if that agent is equipped with a large language model, will interpret or summarize the result, and then the final result is passed to the user. And this is, let's say, a simplified form where we have an input and an output and only one agent, but actually the input here could be the result of processing from another agent, and the final answer, final response here could be passed to the next agent in the sequence. And then we have, I think I will pass a bit faster here because we have a lot of things to show as well. A few things about the session service. So we have in-memory session service and VertexAI session service or database session service. Both can be used for building your application. The in-memory session service, it's simple, easy to instantiate. You don't really need setup or credentials. Production grade alternative for this would be VertexAI session service and database session service. You see VertexAI appears in the name. I don't know if the library will actually be changed because now VertexAI, it's agent platform. We'll see in the future. But across this presentation, you see VertexAI is still there very much, and probably the library name will not be changed overnight. And then you have the ADK memory service as well. In memory service, which is RAM only. It's good because it's fast, minimal setup, no credentials, but it will be rust on rerun. And then you have VertexAI memory bank service. You remember memory bank now, it's called agent platform memory bank, right? So a lot of renames here, which will connect the agent to agent platform memory bank. And again, so this is the preferable implementation if you build something for production. Now, I mentioned that the objective of this project is to build actually gradually, starting from the simplest version, one, let's say, healthcare assistant. We start with actually building a minimal UI over MedGemma, right? And how we do this? First of all, what is MedGemma? So MedGemma, it's a small language model, is derived from Gemma 3, was built primarily for few functionality for medical image interpretation, and it's really, even with the first version, in his more compact form 4B or larger form 27B, was able to interpret multiple medical image modalities, CT, MRI, X-ray, but also histopathology imaging, skin scans, retinal views. Again, it's very important to say it's a not clinical grade model. If you want to use it for clinical application, you'll have to fine tuning for special tasks with your own proprietary data. And also it's used for medical text comprehension, clinical reasoning. The model based in performance may be sufficient for multi-modal application, but it's highly recommended to perform advanced prompt engineering to prepare elaborate prompts if you want to get the clinical grade results. And of course, as I said, the model was initially created for fine-tuning. Yeah, so it was intended to be used from start for fine-tuning. How you can use MedGemma? You can download it from Hugging Face, or you can go to agent platform, not VertexAI, okay, and deploy it. Something that I did just before starting today. And you see, I actually deployed here so that we can use. Good. So I mentioned there are two dimensions, 4B and 27B. 4B, it's great for 2D and high-dimensional medical image interpretation, computer vision text or multi-modal medical reasoning, while 27B will be able to deal easier with complex text or multimodal medical knowledge and reasoning, advanced clinical reasoning, and deeper reasoning ability. So you can choose. Actually, today I will use the compact form 4B. And what I built initially was a very simple application, a query basic agent, which will access a VertexAI endpoint, the one where I deployed MedGemma from Model Garden. By the way, you can do this with just few clicks. You go select MedGemma, you click a button, deploy. You can accept all default settings. Just make sure that you deploy in a region that is convenient for you. So for you guys, if you are in Germany, will be probably one of the Europe West 4 or 3, I think, would be fine enough. For me, by default, is Europe West 4. And so this application can be run locally. It's a very simple, Streamlit UI, and you are using VertexAI just to library just to connect to these endpoints, send the system and user prompt together with the image, and you get a very simple interpretation of the image. So I had this. And actually, if you scan for the project link here, it's the same link, or it's supposed to be the same link as at the start. You'll get one of the recent version of the project, because starting from this, I actually use Antigravity, the agentic ID from Google, to evolve it. And you'll see in a moment how. Before these few words about Antigravity. Antigravity, it's in the same time like code, basic IDE, so it can be used for code editing. You can still manually type, use autocomplete command. You have also inline AI edits. But then you have the agent manager, which is a separate dashboard where you can spawn multiple agents that can work in parallel to different tasks. And so you can have an agent assisting you while developing code, but you can have other agents that are exploring alternative implementation, for example, or work when more complex tasks in the background. And so you have agents across editor, terminal, and browser. The agent writes code for a new front-end feature. You can use the terminal to launch localhost, and you can access the browser to test the new features. So you can do more than one thing in parallel. And looking shortly about what are the most important features of Antigravity, you have this planning, execution, verification sequence. So you can start describing, and you see in a moment how I started, featured in plain English. The agent will generate a plan artifact, a step-by-step checklist that, of what it intends to change. Then it follows with execution. You can, after you approve the plan, then you just can let the agents to do its work, and will create new files, refactor existing one, will run terminal commands to install dependencies to test what is implemented. And then in the verification phase, can use, you'll get artifacts like differences, clear views of code changes, and you can approve overall, or by file, or inside the file, change by change. And then you can have as well other type of artifacts, screenshots and videos, recording of how the agent interacted with UI. And this is very important that agent actions retrieve from can be retrieved from and also contributed to a knowledge base, so the agents can learn from past work. We learn, for example, the patterns you prefer, and so on. Now, let's see how we actually using Antigravity to evolve the initial very simple chatbot that was conversing with MedGemma. So what I wanted to do was to extend the MedGemma chatbot to a healthcare assistant able to analyze images and medical records, to create a full agentic application and introduce guardrails and validations. And so this was actually the initial prompt I used. As you see, it's very simple. Analyze the project structure. I already had a project that minimal chatbot with a few lines of code totally. Suggest how we can modify it, introduce guardrails specific to healthcare domain, functional conversation application, add an agentic functionality, combine medical images with medical records, files. That means medical files, visit notes, and so on. And so during ideation, this is the image. I mean, I didn't spend time to create this diagram. This is one of the artifacts while Antigravity was performing the planning. So based on my instruction, he created this image. And actually, this is what he implemented in the first step of evolving the healthcare agent. So from the simple image analyzer, he created this structure where the input could be still medical image, but also medical records and also text queries. And then it had 3 stages. Stage 1, in stage 1, perform several validation, input validation, PIA detection, emergency detection. If it was a real medical emergency, to act immediately, and safety checker, protect against people that are trying to use a medical, the healthcare assistant to ask about, all kind of pseudo-medical problems or totally non-related to domain. So we put some guardrails in place to not force this application to be used for other reasons. And then the agent processing, here you have a routing agent that, depending on the modality of the input, will route either to the image analyzer or to the medical records analyzer, or for both. And then will synthesis agent that will use also reflection, will summarize the output of these specialized agents, and if necessary, we'll have also a reflection loop. If we are not happy with the result of synthesis, we can send the partial result to routing agent. This will decide if to pass also to the one of the sub-agents. And then the validated, and then you have the output validation. Of course, this will use also the conversation memory, state memory, and also the history of the conversation, but also data that was produced during event processing loop. And you'll get as outputs structured findings, comprehensive report, so various types of outputs. Could be the image analysis report or medical report analysis. This is the structure actually of the classes. So initially, the initial implementation will only use MedGemma for image analyzer, and all these agents were not equipped with LLM. So I force it actually to add LLM to all these agents. So because after the initial iteration or iteration of this agent, I was not really happy with how it was functioning. So I did, let's say, a semi-manual phase where I forced Antigravity to add a new feature. And some of this feature was to, okay, so this routing agent, I don't want to use only predefined logic, also use LLM to for the regioning part. And everything was in place, a lot of classes, a lot of files. Let's say logistic nightmare, but for one developer like me, but for Antigravity was fine. I was using the models behind Antigravity, like the models that will do the heavy work, where Anthropic Cloud and Gemini 3.1. And this is also something created by Antigravity, so a report of his initial effort, right? So the design he did, the data models, guardrails, conversation agents, everything he put in place, number of files for each, the key features, summary of the architecture, statistics about the code, implementation, test he did. So I summarize here the really the activities by Antigravity. You see, not only the initial plan execution and adding new feature, but also I had to do a bit of bug fixing, incremental user guided improvements, because I was not really happy with the initial thing. And this is how the application actually looks like. To run the application, because I was, as I said, a bit late, but also a bit early, we'll have to just a moment. We'll have to download actually don't know if we'll have time to do it. But anyway, so let's try to do it this. What I'm trying to do is to get a fresh version because now I have the ADK version on local. I want to get a separate repo with a version from main. And I will do this. So I'm cloning here version, and I think I also need to do okay. Okay, good. And what else? I don't guarantee that this is still working because I had to do a bit of refactoring. It might not work at all, but let's see what we can. So this is the version of the application with the agentic implementation, but without ADK. So I started locally. Hopefully, yeah, it's initializing. So while this is working, I will get back. So take a look. So this is how this version of the application look like. It has guardrails in place and can do the image analysis as well as medical report analysis. Okay, let's say yeah, so let's see if, I don't know how this is name actually. Tools. Yeah, so you say, okay, if I ask some stupid question, they will snap my hands. Let's. Okay. I think this will not work because in my environment, I didn't set It's fine. Oh, okay, good. So I was apparently not so drastic change. So I was afraid that because I copied the environment, some thing would not be tested, would not be set correctly. But okay, so you see, I have the image interpretation. I can also um, maybe try to interpret the medical record, but for now, I think it's fine. Let's go to the next phase because we can. Okay. Again, so if you want to get the project link, remember on main you have the second version, the step one of the evolution. On the ADK agent branch, you'll have the third step, the second step of the evolution. And for this step, I actually turn back and again, talking with Antigravity, I prompted to rewrite the entire application in a simple way by replacing the ad hoc agentic application with ADK-based agents. So I didn't want it anymore ad hoc agents. I wanted everything to be built around ADK. And also, I wanted to keep and extend guardrails, but if possible, to make a simplified version of it. And yeah, and here you see this is the new schema of the application. We have an orchestrator agent which use 4 agent tools: a record parser, image analyzer, synthesis agent, and Q&A agent, and each of them will have tools. So this is the basic structure with ADK where we are implementing not coordinator agent with 4 agent tools, and we also have implemented guardrail callback, something that is called in the main event loop before anything happens. So an input will be first passed to the guardrails and evaluated there, and only if we pass the condition there, the orchestrator will continue and select according to the appropriate action one of the tool agents that he's using. And at the end, after everything is processed by a tool agent, will be sent back to the orchestrator that will prepare the output using other agent, for example, the synthesis agent, and then we'll get the output. So the mission here was, as I said, to rewrite the agentic application, to simplify the workflow, write the validation, and well as using a before agent callback. And I'll stop this, and now let's see. Close these various version, and let's see what we have here. Okay. Now we are starting the version implemented with ADK. Just a moment. I'll bring back. Okay, so here you see this is the main agentic structure. We have the root agent, which is the orchestrator. It's actually, his name is MedSite Orchestrator, and which is equipped with these 4 agent tools: image analyzer agent, record parser agent, Q&A agent, and synthesis agent. Each of them will have its own tool, and before the agent callback, we have this guardrail callback. Let's try it. Okay, so I'm testing the guardrails now. I don't remember exactly what is in there, but let's try one more thing. Yeah, so I tried different, I don't know. Okay, so apparently this, let's try, because we didn't try with the previous version of application, let's try to interpret one medical report. So I just load the medical report and we'll see no, how this is working. And while this is running, we just have a few more slides. Okay. Yeah, so this is supposed to see in the output. We'll check in a moment. So this is the analysis of this medical report. Now, it's still working. So to save some time, maybe I will just jump to the conclusion before showing. So what I wanted to show you today is the not VertexAI, but agent platform functionality. So everything is reorganized now around developing agentic centered application using the most powerful models. Good option could be to use Gemini series, but today I use both Gemini and MedGemma, which is one of the small language model in which is very close related to the Gemma series of small language models from Google. I saw how anti-gravity can be used to actually evolve with a minimum assistance your application to something which can really evolve. And in this evolution, I saw how I went from a simple chatbot, which was just analyzing images, medical images, equipped with MedGemma, which was deployed in a VertexAI endpoint, to a full agentic application, and then dropping that pretty complex agentic application that was first imagined by Antigravity. I created a more compact, using only EDK agents, more compact agentic applications, still keeping most of the functionalities. So here is the answer. I saw the medical report is analyzed. So we have this very well structured. We have diagnosis, medication, procedure, key dates. Of course, this structure is specified partially in the how to say its own brain of MedGemma, but also partially in the instruction we gave for sorry, for this is not using MedGemma, it's using Gemini. So partially it's the own logic of Gemini, but also in the instructions prompts that we are using. I'm stopping here because although I was late, I don't want to be late also when finishing. Thank you very much for your attention. If you have questions, I think we can have a few more moments, maybe.